skydiver jumps from a plane, how long until he reaches a speed of 56? Okay. Opening. Okay. So 1. U is 0, B is minus 56, A is minus 9.81, and I want the T. Oh guys, wait. If you use plus, that's okay. If you're using plus, that's fine. That just means for your question, down is plus and up is negative. But I'm going to try and stick to using down is negative and up is positive. But if you use plus, that's fine. Okay. V squared equals... No, I don't want that one. No. What do I want? I want the time. Yeah? Which one do you think? V equals U plus AT? Yes, okay. So you have T is 5.7?
Yes.
So T is 5.71 seconds. Next. Next. What the heck? CCC? No. A. The skydiver opens his parachute and decreases his speed to 1 meter per second over 6 seconds. What is the drag force during this time? Okay. So that's A. That's B. So what happens here? He is. Oh, we'll make it a girl this time. Opens the parachute. Yes. So here the U is minus 56. The V is minus 1.
Why the U is minus 56?
No, it's okay. If you want to make it plus, that's okay.
No.
Oh, why is it minus 56?
Yeah.
Because what's happened is the skydiver jumped. Oh, I did say his actually. And they go from 0 to 56. I'm sorry I wasn't clear. And then when they're at 56, they opens the parachute. Yeah.
Because I think the U maybe is 0 when he jumps.
No, when skydivers jump, first they jump and then after a few seconds, then they open. Yeah. V is minus 56, B is minus 1, A we don't know, T we do know, S we don't know. Okay, I really want to know what the A is. V equals U plus AT again?
Yeah.
So I got A is 9.17 meters per second squared. Minus is fine. Grace, did you say plus here? Then if you said plus here, you should get minus here. That is correct. What's wrong? Did you get minus 9.17? That's right. Because you said plus and plus here at the start, yeah? Yeah, that's fine. Okay. Right. So how many forces are on this parachuter?
It has to be negative, right?
Oh no, this sign thing is coming up again. I'm calling down negative and up positive. So because she is...
she's decelerating.
Yeah.
Oh.
That's the exact same question
okay.
you asked.
Sorry.
Yeah, that's okay. Is me calling down negative? I thought I would be helping. Is it making it more difficult?
No, I understand it.
It's okay?
Yeah.
Alright. Right. If she was falling, what should her acceleration be?
9.81.
It should be 9.81, but it's not. It's 9.17. There are two forces on her. What are the two forces?
Drag.
The weight, yeah, and the drag. Yeah, or lift, or whatever you call it. The drag, yeah? So, if I say F equals MA, I should have minus W, or if you want to... Huh? Is it... No, I think this is still B. Yeah. Drag minus W, because this is going down, it's a minus, equals, what's the mass? 60A. Drag equals W plus 60A. What's the formula for W? mg, isn't it?
But why is it drag minus weight and not weight minus drag?
Again, if you were calling down positive, it would be weight minus drag. But
Oh,
because I'm calling up positive, it's drag minus weight.
okay.
Oh, these signs now, yeah, it's not going great. But you should get the same answer with just a different sign.
Even with the different sign.
Yeah. 60 times 9.81 plus 60 times 9.17. And I get drag equals 1138.8 newtons. So about 1139. And before you ask, if you got minus 1139, that's fine. Did you get minus 1139?
No,
Okay. What did you get?
something else.
Close to 1000?
I didn't do this one.
Alright.
This.
Um, Here, which do you think is bigger, drag or weight? Which is bigger number?
Wait.
The weight is
No, drag.
Right?
but drag is if drag is bigger, it will go up.
Exactly. That's the answer for part C. Will this stay the same? And the answer is no. The drag is bigger than the weight while it's slowing her down. But it won't stay bigger because, as you pointed out, then she would start to move up. So after a few more seconds, part C, the drag will then equal the weight. And so she'll come to Earth at a constant speed.
Okay.
So the answer for part C
Yeah, I
is
know that it won't because constant she'll be falling with a constant velocity. So
drag needs to equal weight
yeah,
so
it
she can
needs
fall with
yeah.
constant velocity. Yeah, that's it, yeah. Okay, can I do the next one?
Why drag minus weight?
Why drag minus weight?
Why wouldn't
Yeah, why is it minus weight?
Well, up is plus and down is negative. So for example, if this was 10 newtons and this was 11 newtons, what's the total? Is it 21?
one?
1. 1 up or 1 down?
Uh,
1 up or 1 down?
one down.
So it's 10 minus 11.
No.
No, okay. What's your question?
This question here is asking for drag.
Yes.
Okay, no question.
Okay, great. Can I continue?
Yeah.
Yeah.
Yeah. A bullet is fired vertically upwards at a speed of 300 and the terminal velocity of a bullet is 150. How long till the bullet hits the ground? Hint, ignore the drag on the way up. Okay, so this one here, number 2, what happens is you fire a bullet up into the air and then it comes down. So let's look at the first part of the journey, up to the top. That's the bullet. Up to the top. So the U is 300. The V, 0.
Yes.
T, don't know. A, minus 9.81 and F.
But then it's not minus 9.1 when you go up, right? When it shoots up. That's what I was confused about.
It is minus 9.81.
When it gets shot up.
Yeah.
Why? But isn't the force from the gun taken into
Oh
consideration?
no. No, not at all.
So even if going up it's
Oh yes,
basically
yes.
positive 9.81.
Negative
Yeah.
9.81.
When it's going up,
It's gone up.
it's negative 9.81.
Yeah.
Why is it negative?
As
Oh,
great.
it's going down. Okay, got it.
Okay.
Huh? What?
like Grace said last week, it's always minus 9.81. Because the weight is always going down. Even if the bullet is going up, down, or sideways, the weight's always going down.
Okay.
Yeah. Okay. I want the t. So which formula should I use? B equals u plus at, isn't it? So what did you get for t for this part?
I didn't do this one because I was confused.
Okay. Okay, that's okay. If you say b equals u plus at, then you'll get t is 30.6 meters per second. Now I think that answer's too big. I think I made my bullet too fast.
Unit is wrong.
And the unit is definitely wrong as well. 30.6 seconds.
5, 8.
Huh?
13.5, 8.
Okay. 30.58 seconds. Now the next part is from here. The bullet will fall. But
How
yeah.
about here? This going down.
Yeah, I'll show. I'm doing it in 3 steps. So it goes 1, 2, and 3. So this is the bullet on the way up, and then this is the bullet on the way down, and then I'll explain this piece in a moment. Okay. Now I said here that on the way down it's a little bit different. So the bullet starts off at 0, but the V here, there's a maximum speed of 150. This is called the terminal velocity. It's the fastest the bullet can fall. Why can't the bullet fall faster than this?
Because of the drag.
The air slows it down. Yeah. So what's the A though? We'll still say that the A is roughly minus 9.81. That should be minus 150. I know it won't be minus 9.81. Should it be bigger than 9.81 or smaller than 9.81? Smaller. So we'll just say it's roughly 9.81. So I want the time. So again, V equals U plus AT. So I get T is roughly 15.29 seconds. And then for the last part of the journey, it goes from 150, but it stays at 150 until it hits the ground. It doesn't go any faster. So here there's no acceleration. So this is just a good old dad's silly triangle. I want the time, so that's distance divided by speed. But do I know the distance?
No.
No. So actually, maybe I will have to use my UVATS. UVATS. U minus 150, V minus 150, A 0, T don't know, S I don't know. What formula can I use? S equals U plus V over 2 times T? No. V equals U plus AT? No. S equals UT.
It's unsolvable.
No, it's not unsolvable. It's a little bit more difficult. What I need to do, look, I need to get the S here to know this distance, and then I need to get the S
And then minus it.
yeah. So let me get the S at the start. S equals U T plus a half A T squared. So here the S is 2 big, 4,587 meters. The S here.
Oh my.
Yeah, I know, I made the numbers too big. And here for the second part, from here to here, the S again, I'll use the same formula. S is U, which is 0, T, which we have as 15.29, a half A T squared. So here it is, S is 1146. So if I just go to the side, 4587, here I said it's 4587, and then on the other one, 1146, 1146. So then how much is this piece? Well, 4587 minus 1146, 3441. So for the last part, it's 3441. So distance, speed, time. Time is distance divided by speed. So the time is 3441 divided by 150. So time is 22.94. So it's this one plus this one plus this one. Yes.
I forget why the third part, A equals 0.
For the last part, you say that the 1 second. When the bullet is falling, its speed stays at 150. 150 is its maximum speed. So it's not accelerating, it's not getting faster. It's just going 150, 150, 150.
It's not minus 5.81.
Not anymore, yeah. Because for the last part, the air drag equals the weight, and they cancel. Okay. I think I should change this question from a bullet to a rocket.
Why not?
Because this is too big. Just something, not a bullet. Okay, can I do the next one? A 1200 kilogram car will accelerate to its top speed of 160 over 20 seconds. What is the drag force? Okay, 1200, 160, 20. Okay. There's my car. And it'll go from 0 meters per second to, what did I say, 160 kilometers per hour. And it's mass is 1200 and 20 seconds. Yep, I should change this into meters per second. Did you get 44.44 meters per second? Yes? Okay. So U is 0, V is 44.44,
Yeah, same thing.
A good, T is 20, S. Okay, I really want to know what the A is. For sure? Seems kind of small. 2.2 or 2.22 or 2.2.2?
I'm not sure.
Okay, let's check.
For some
Or 2.22 maybe, alright.
with some point.
With some point, okay. Oh no, not this formula. I should use
U equals V.
B equals U plus AT. Okay, it's not that big. 2.22.
Yes, a ballpark.
Very good for you. Okay. Have a look here. There's a force which is driving the car forward. Look. I'll call this force T. Are we looking? Yes? Yes? At the end, this force is still the same. It's still T. However, there is a force at the back here called the drag. and there's a force at the back here. But at the beginning, the drag is 0. Why is the drag 0 at the beginning?
Because it's not started.
It hasn't started.
Oh.
So you're right. So roughly, on average, how big will the drag be? It'll be drag divided by 2, because it's the average of this number, the average of this number and this number. You divide by 2. Well, imagine it starts off with 0 newtons, and at the end it's 1000 newtons. In the middle, what will it be roughly? About half of that.
Aren't we supposed to divide it by the second when so each the average of each second the drag is that much?
Yeah, now you see, this is an approximation. You're right. But you said divided by time to get the drag per second, and it'll get very messy that way. And in fact, when I calculated the exact answer, this approximation was still correct 2 decimal places. So this approximation is a suitable one to use. That you can say it goes from 0 to drag, so on average it's drag over 2 is the force. You still asking me about drag over 2? Is this okay?
No.
No. Are you happy with this?
Yes.
And you're happy with this?
Yes.
So in the middle, which will it be? Will it be 0 or drag? And let me call this D instead.
D.
It won't be. It'll be smaller than D, because
It's supposed to be D minus 0 over 2, right?
yeah, I suppose so. D plus 0 over 2.
Oh yeah, sorry, plus 0.
Oh yes.
Yeah, what happens is
No, but it's supposed to be minus if you want it to be in the middle. It's
no, you're taking the average. So you add 2 and divide by 2. Yeah.
okay.
You know, the drag starts at 0, and then as it gets faster, what happens to the drag? It gets bigger. Until the drag equals the t at the end. So while it's getting faster, it'll be wrong to say the drag is 0 or the drag is d. There must be some value in between. So roughly we'll say d over 2. Okay. Alright, so what's the total force here? It would be T minus D over 2. Yeah? But look here. In the last picture, what does the D equal? The T. They balance. So here you can replace the, what do I want, the drag or the force? The drag. So here you can replace the T with D. Here. So this means you get D over 2. So, therefore,
D minus D over 2 is D over 2.
yeah, D minus D over 2 is D over 2. So MA equals D over 2. So that means D equals 2MA. And what did I say the mass was?
I don't know.
Huh?
Uh.
Yes.
1200.
1200. 1200. And the A was 2.22.
Oh.
Yeah?
Yeah, compared to 1, 2. No. One. No. Divided 2.
You always forget to divide.
Because it's A.
It's okay. Alright, so we get 533 newtons. Yes? Okay. Can I go to the next one? I want to start the next lesson, so I don't have time to do this one. I'll have to do it the next time, okay? Alright. So, to be continued.